Welcome to Southern Manufacturing Technologies. I'm Roy Sweatman, President and owner of SMT. So SMT is a precision custom manufacturer. We use computer-controlled machine tools to cut metal and take a block of metal and shape it into a part that goes into an airplane. I bought a small company in 1983 that had 5 employees, and we grew it from there to where now we have about 100 employees. Over the years we found different customers, and one of them turned out to be making valves for satellites and those kinds of things, and so we wind up making parts that go on Mars and other space satellites. I got into manufacturing kind of by accident. I was raised on a dairy farm. After graduation I went to get a summer job at GE in Erie, Pennsylvania, and found out that they wouldn't hire under age 18 unless it was for the apprentice course. And so I found out that the apprentice course was a 4-year machinist apprenticeship, and so I've been involved with machining ever since.
The lack of manufacturing awareness is a really big problem because fewer and fewer younger people were going into the manufacturing industry, and so there's a large age gap in a lot of manufacturing companies where there's an older workforce that's going to soon be retiring, and while we have new automation and technologies that allow us to be more efficient, we still need a workforce, and in a lot of ways that means we need a different type of workforce than we've had in the past. We need people that can understand how robotics work and how to program equipment, maybe more than running the equipment manually, which were some of the skills that were more needed in the past.
So many of the parts that we make are used in areas where if they fail, the lives could be at stake. If you make a part that goes into a fuel control for a 737 and something fails, you don't want to be the one riding in the airplane when that happens. We also parts that are used in missiles, and so if a soldier is firing a missile and being fired upon, he needs to make sure it's working. So we have to make our customers design the parts, so they design them to work in their systems. We just have to make sure that we make them to the dimensions and the specifications that they call for, and that can get into very, very close tolerances, down to 2/10,000ths of an inch, if you can think of what that might be. We do inspections all the way through the process. The operators, as they're making the parts, are checking them to make sure that they're within the tolerances, and then we do a final in our final inspection area.
My name is Al Card. I work here at SMT. I'm in quality control, and been here for 26 years. This piece of equipment is called a Kiosk. It's very, very quick at what it does. So because it's only looking at the part, in this instance, an operator could come in, put the part on the glass, and push the button, and in 6 seconds, it's going to check 96 different dimensions in 6 seconds. And it's going to tell us whether or not it's good. And right here, because it doesn't say NG in red, it's actually a good part. 96 dimensions in 6 seconds. Typically that part would take about probably a half an hour to 45 minutes on other pieces of equipment, so all that time savings is important to us. This part right now is being checked, and each one of the beeps are a very specific X, Y, and Z location. The piece of equipment will take those specific points and create either circles or lines or planes on the part. As it's going right now, it's actually scanning. You stop hearing the beep right now, but it's actually recording XY coordinates and sending them back to the piece of equipment over here. And every 10,000ths worth of travel, it's recording a point. Though it looks like a white line on the screen, it's actually a whole series of points. We're able to recall any one of the data points and actually compare them against the print and find out whether the part is in or out of tolerance.
So Aerospace and Defense is a very broad category, and we make components that go into piston engine airplanes like a Cessna or Piper that a private pilot would fly. We make components that go into 737s, jetliners that you would fly on if you're going from here to Chicago. We make components for missile systems, the Javelin, Tomahawk that our military uses to protect us all. We make parts that go in satellites, so we've been part of the trips to Mars, the rover, the Curiosity, the Perseverance, it's on its way now. You know, we also make medical parts, and if you want to be part of the space exploration, going to Mars, going to the moon again, you know, working in a company like SMT, you can hands-on make the parts that help get the astronauts and the people where they're going.
Welcome to our shop floor. We have 20,000 square feet here and 22 CNC machines. So a CNC machine is a computer numeric controlled machine. What that basically means is we can program the machine offline on just a computer, and we use a 3D model to do the programming, and then the machine reads the program and is able to repeat making the same part over and over. So now we're at our newest CNC machining cell. We have two DMG Mori NZX machines. One's a 1500, one's a 2000, so they're a little bit different size capabilities, but otherwise they have the same machining capabilities. And we have our brand new Fanuc Robot, and Prime Test down in South Florida helped us do the integration on that since it's our first robot. And we pretty much just got it up and running last week, so you guys are the first ones to get a tour and see our brand new equipment up and running.
So here's a couple of examples, guys, of the tools that we use here in these machines here. This is a lathe turning tool, and the way this works is we have a very super hard piece of carbide right here on this tip. So the tool comes in like you saw in the video and actually forces the material away with the turning of the spindle. The spindle turns and this tool comes in here stationary and actually removes the material away. Now this is a boring bar. This is what we'd use for inner diameter work. So this will come inside of a bore, and it'll come in and it'll make it out with that same carbide tool. Now the cool advantage of this carbide tooling here is once this tip here wears out, I can just loosen this screw here, pop the carbide insert out, and then put another one in, and my machine goes right back up to running. Now that saves us a lot of time compared to how they did it 30 years ago, where the guys would have to take the whole tool out of the machine and go to the grinder and actually grind themselves a new tool. Now we just replace the tip of it and we go right back to work. My favorite part about this job is the technical aspects. It's very challenging. There's always something new I have to walk into every day. It's not boring. I come in, there's something different going on. There's always new problems to fix and to overcome and new challenges, and it's just pretty fun to do. My education didn't happen overnight here. My apprenticeship program is took me about 3.5, 4 years to finish, and I'd say about 50% of my education came from school. The rest of my education came from hands-on learning, hands-on experience here in the shop. Learning from these guys that are 60 years old that have been doing the trade here for 30 plus years. That's where all the knowledge in this industry is, and you got to physically pluck it out of these guys' heads to get that knowledge. A book can only take you so far in this industry. One of the main things I did a lot was I watched a lot of YouTube videos. You can learn a lot off of YouTube. In my spare time, instead of sitting around watching Comedy Central, I would watch a couple machining videos on YouTube. And it really did help me get that extra step up on the rest of the people that were in class with me. And they're like, man, how are you so far ahead of me? How come you know so much more? And, well, that's because I obsess about it in my off time, and that's how I got to where I am today.
So this is one of our horizontal CNC machines where we're making our ventilator parts right now. Basically, we take a solid piece of metal like this and use cutting tools in our CNC machines to turn it into the finished product. And so what we first have to do is design a fixture. And basically the fixture is what's going to hold the part in the machine. So while we're machining the part, it has to be held in place so that it's not moving. And so that's a really important piece of the puzzle here. And so basically the fixture would be holding the part, and then the machine would come in with cutting tools and machine it. And you'll do one side, and then we flip it around after it's machined one side, and then we'll machine the back side of it. And the horizontal mill has the capability of the pallet is able to turn while it's machining. It has a fourth axis on it, and so while it's machining the front side and it turns the part, it can get to these side holes and do everything with just basically two fixturing. When we talk about horizontal or vertical mills, we're talking basically about the direction of the spindle. So a horizontal mill has a spindle that is horizontal, and so that's why we have the pallet here loaded up with a tombstone on it, and then we mount fixtures onto the tombstone that will hold the parts while we're machining it, because again, horizontal spindle is going to come in and do the machining this way. And this has a fourth axis, so basically the pallet can be spinning while I'm machining, or we can come in and get to the side of a part if we need to by doing that. So now we're back in our saw room, and this is pretty much where everything starts. Most of our material comes in 12-foot long bars, and so we load it onto the saws, as you can kind of see here, and then we're able to set their automated saws. So basically we have them set to cut at a certain speed and feed rate, and it will cut through the material, raise back up, and then automatically advance the material forward and cut the next piece. While we do a lot of CNC machining, we still have a handful of manual machines here, and really this is where machining began. If you're going to learn to be a CNC machinist, you want to learn the basics and the foundation of manual machining before you do CNC machining, because if you're trying to troubleshoot a problem on a CNC machine, you can't feel what the machine is doing. But if you have that background knowledge and kind of, okay, I know, oh wait, maybe the tool is catching a little bit while I'm doing this, or maybe, you know, we need to increase the speeds or feeds because you know what it felt like previously to do that type of thing, it'll definitely give you an advantage of being a CNC machinist in the future as far as troubleshooting and really being able to optimize how that CNC machine runs. You know, the manual machines have an advantage and they also have a really big disadvantage. So with a manual machine, you have to have a person there every second that it's running, and you can't walk away from it. So one of the great advantages of a CNC machine, besides the fact that it just repeats the same part over and over again, is you can walk away and you have time to go inspect the part while the machine continues machining. In a manual operation, you are literally moving the machine for every single step of the operation, and so you have to be physically there at all times. And so to be able to ramp up into something high volume on a manual machine, you would need, number one, a bunch of manual machines and a bunch of people that are skilled enough to be able to do that all at the same time.
We've got several kids here that are in school for engineering, and they're going to pretty much be able to write their own paycheck when they get out into the job market because they've got that 5 years experience here in a manufacturing environment plus their engineering degree. You can go so far with that experience, but the main thing is the experience. The experience walks.
You all are on a virtual plant tour of SMT. In the past, we've done actual tours where the students would come in and be able to walk around and see what was going on. And one of the students that did that a couple years ago, he got involved with BattleBots and was building a BattleBot for competition. And he remembered us, and we made parts for robots, and so he contacted us, and we became one of his sponsors and made all the machine components for the extinguisher. It all started with a tour that he saw what we could do, and when he needed that kind of thing, he came to us.
A few of my friends work here. They were the ones that were in charge of making our parts. It's a 250-pound fighting robot for the TV show BattleBots on Discovery Channel. So my freshman year of high school, we did a walkthrough through their shop space, and that was when we had the older robots that didn't really have any precision. After we got accepted to the show, we kind of needed to do a little bit more precise things that were neater and tidier and worked better. Our application was just sitting in their pool, and then they accepted it, and we didn't really have any idea who to call to. We talked to our teacher at school, and he remembered we came here for a walkthrough and then put us in contact with Roy. So with SMT, they've taught us a lot about how to make components designed for manufacturing, and then they manufactured all of the parts for us.
Team Gruff is another BattleBot that we sponsor, and we actually have one of our employees here that is part of that team. So we got involved with Team Gruff, again from the school tours, and our working and our involvement with schools like Eastlake High School and Middleton High School and that sort of thing. And when they were building Gruff, then one of our employees, Jason, was part of the team, and we knew the other members of the team, and they wanted us to help them make the parts, and so that's how we got involved with them.
My name is Jason Ryan. I work here at SMT. I operate this set of machines behind me. They are some of the biggest and some of the highest production machines we have in the shop. They are all horizontal mills. They are a cutting machine that takes these cutters that are actually right behind me in this whole belt, and it cuts them on a horizontal axis. I operate those machines, I set up those machines, I build these tools. I started going to college straight out of high school. I went to the University of South Florida. It was kind of like a, what do you do? High school's over. I've got the qualifications to go to college. I didn't know what I wanted. I got to USF. I started studying engineering. I met up with some really good friends there, namely a friend of mine, Sam McAmis. He got me into a robotics group over there. And what that group did was a lot of different levels of robot competition.
I'm Sam McAmis. I'm the captain of Team Gruff on BattleBots. The National Robotics League is like a college and high school league, so we competed against different colleges as well as high schools. And then Robo Games was just kind of like amateur fighting robot builders from across the world. The biggest like worldwide robotics competition. Now we're professional doing BattleBots, and they also support our high school team up at River Ridge High School.
I've gotten myself to the point where I have a valuable skill, something that I can continue to use here, something that I possess, and it hasn't cost me anything. So it's been a great opportunity to advance myself in life. I think that's my favorite part about my career here at SMT.
We're turning up the heat this season. Team Gruff, let's go!
If you have the right attitude and aptitude, you want to come to work every day and be excited about what you're doing and work hard and want to learn and grow and continue increasing your skills, that's what we're looking for in an employee. And so I try to talk to the students about those types of skills that manufacturing companies are looking for. Manufacturing's not for everybody, but if you enjoy working with your hands, if you like math, if you think it would be really interesting to start with a solid block of metal and come out with a finished product at the end of the day, then a manufacturing career might be for you.
The apprenticeship program is valuable. That's the way I got my start in manufacturing, and I've gone from being an apprentice to a business owner. And so that on-the-job learning, when you're done, you've got tremendous skills that can get you a great career for the rest of your life. There is no tuition for apprenticeships in the state of Florida. State of Florida actually subsidizes the related training that you would get at Pinellas Technical College and potential career that is every bit as good as any college graduate.
Well, thank you all for joining us here at SMT today virtually. We wish we could have had you all here in person. So if you're a high school student wondering, what do I do if I want a career in manufacturing? That company looks pretty cool. You could reach out to me directly at hr@smt-tampa.com and submit a resume to me. You might be wondering, well, I don't have any work experience. What do you actually expect from me here? We're just looking for, tell us a little bit about yourself. Let us get a picture of who you are. If you have relevant classes that you've taken in high school, list that. If you've done any volunteering, worked any side jobs, won any awards, any of that type of stuff, just try to help us get a little bit of a picture of who you are.